Hmm. We are live. I can see my live, but the link is not showing me on YouTube. अरे ये क्या हो गया? क्या से क्या हुआ? Huh? We are live, but I can't see anything on the YouTube channel. Yes, now I can. हेलो बच्चों, वेलकम. सो बिफोर वी गो फर्दर, मैं एक बात बता दूंगा which I say every day, which is very important for you guys. I want you guys to keep your distance, stay at home and stay safe. All right, stay at home and stay safe. I know this is tough time for everyone. Okay, it's tough time for everyone in the world, not just our country. US में भी elections भी कर रहे हैं without this. Everyone is voting from home. If you see, US में सब voting घर से खेल रहे हैं. तो इस तरीके का सिचुएशन है सब जगह. So I want all of you guys to stay at home, stay safe, and keep your distance, keep your social distance like the guy here. देखो वो एकदम एकदम रिलैक्स कर रहा है, बट देन जैसे ही कोई आ रहा है तुरंत ये निकल रहा है. So this is this is a wonderful depiction. Stay at home, stay safe, wash your hands regularly, and crack IIT-JEE while staying at home with India's largest platform, which is Unacademy. All right. Now, not only that, get the Plus subscription to access unlimited live and recorded courses from India's best educators. Get the Plus subscription by using this code NSS1. By using the code NSS1. NSS1 is the magic word. Use it and you will crack it. So one more thing, we have this is how the app looks. Unacademy app. Install that app right away. We have daily quiz shows happening there. One of the show is by me. It is called the daily quiz show. It happens at 10:30 p.m. every day. All right. So about me, कुछ बता दूंगा. I'm N Srikant. I did my BTech from IIT Kharagpur. I have it in the year of 385. I've been guiding young minds for the last 4+ years. You guys call me a human calculator. Let's see why. And Sunrisers का fan हूँ. कल भी अच्छा मैच हुआ था. And DC is equally marvelous, if not better. Yes, I'm a big DC fan. If you are Marvel fans and you do not want, if you disagree with me, feel free to hit the comment section in the YouTube channel. And before we go further, I want all of you guys to hit the like button. यार like से मुझे पता चलेगा how many of you are liking the video so that I can feel more enthusiastic by it. All right. So definitely like करना मत भूलो. Hit the like button, share it everywhere, make these videos viral. So this is the program I've launched for you guys. It's called Ad Astra. It means aim for the stars and crack JEE. This is extra which I added. But Ad Astra meaning aim for the stars है. Aim for the stars, and while you are thinking big, on the way एक अच्छा इंस्टीट्यूट में भी चले जाना. ठीक है. Always you should have your eye on a bigger target, which is not an institute. It is developing something of your own. Okay, so that is about Ad Astra. So this is the 6th class for on current electricity. जैसे कि हम ये देख रहे हैं, this is a wonderful visualization which I loved, so I'm putting this in every class. And this is a wonderful visualization which I want everyone to understand. ठीक है. So this is how current is flowing. This is the flow of current. ये जो भी है, ये जो ऊपर जा रहा है, यहाँ पे ऐसे जा रहा है. This whole thing is the flow of current. All right. Now, how is current flowing? This is what will give you the best idea. ये positive terminal है, ये negative terminal है. Current is taken from negative terminal to the positive terminal by the battery. The battery will make sure this is happening, and this current will flow through this. And remember one thing: resistor is like a speed breaker. Resistance is like a speed breaker for current. नहीं तो current का speed infinite current हो जाता. So to avoid that infinite current from happening, the resistance is like a speed breaker. It will stop current to maintain speed. So what will happen? So how does it happen? So it is going down with resistance will always allow current to flow through it downward. Okay, resistances are like river. It's like river in the bed. River bed will be very rocky. It won't be plain. It's like a river bed which will allow water to flow. So here also this resistance will allow current to flow through it from higher potential to lower potential. Provided this has higher potential and this has lower potential, current will flow through this. The quiz is at 10:30 today, Ramesh. Welcome to the class and stay here. Okay, don't go anywhere. We will do a lot of problems today. Lot of problems on condensing circuits and solving circuits. Okay, so this is negative to positive terminal. So whenever the main concept is whenever there is a positive terminal to negative terminal, the potential is rise. It is rising. and in resistance the potential will fall. A capacitance also, when negative positive is there, the resistance the voltage will rise, and positive negative is there, the voltage will drop. Remember, positive will always stay at higher potential than negative phase. Okay, so little that was done. So we also discussed yesterday about Kirchhoff's laws. So we'll do look a little into what happened yesterday, then we'll start getting into problems right away. So Kirchhoff's law का condition क्या है? So a metal does not accumulate charge. Charge accumulate करने से metal के अंदर you will have field. There will be field inside the metal, but that is not possible, right? Inside a metal the field will be zero because any charge inside the metal will always go to the edges. तो वही लॉजिक से अगर देखोगे तो यहाँ पे अंदर जो भी करंट है, करंट metal does not accumulate charge. So it is like a junction. Imagine a junction where there is nothing, no one is stopping in the junction. Suppose 5 cars are coming here, 10 cars are coming here, some 2 cars are coming here. How many cars will go out of this? 17 cars, right? You know, this is 5, 2, and 10 are coming in, 17 will go. This is the basic intuition we also use in this current. The total current across all junctions, if I1 is coming like this, I2 is coming like this, I3 also is coming like this, it means I1 plus I2 plus I3 will be equal to 0. This is what it is. We can also be explained by saying current coming inside, current into the junction, this is called Kirchhoff's junction law, is equal to current away from junction. Okay, this is a very simple description. Current into the junction will be same as the current which is going out of the junction. So you can also say invert like this. You can say I1 plus I2 plus I3. If it's going outwards also, you can say I2 plus I3 plus I1 will be equal to 0. Either ways, it will mean the same thing. Okay. The next thing we discussed was Kirchhoff's voltage law, or it is also called as the loop law. So in this, you have to take different kinds of loops. The potential difference across different, the sum of in a closed loop, the total potential difference will be equal to 0, which means like we discussed. So when like we discussed here in the previous question, like the previous image, like in this diagram, if you observe, if you start from this point, go the entire thing and come back to this, you are at the same horizontal level, no, same ground, you are at the same horizontal level. Similar to this, here in a closed loop the potential will remain 0. Okay, so simple example here, एक छोटा सा example है. तो यहाँ पे 12 volts का battery है. So the resistance are 10, 20 and 30. So total resistance is 60. So I will be equal to 0.3 amperes as shown in the diagram here. So उस तरीके से अगर if you see the potential difference across each resistance, if you see the potential difference across each resistance, this resistance will have 2 volts, this resistance will have 20 into 0.2 which is 4 volts, and this resistance 6 into 0.2 which is 30 into 0.2 which is 6 volts. So if you observe this, initially it is rising up by 12 volts and then slowly falling down 2 volts first, then falling down 4 volts next, and then falling down 6 volts. Eventually you will come to the same level, which is the same potential. Clear? Okay, next we discussed about Wheatstone bridges also. The configuration in the adjacent figure is called a Wheatstone bridge. The current in the galvanometer, or we'll discuss about galvanometer also today in the class. Let's see at the end of it. Galvanometer can be used as a current measuring device. Okay, current in the galvanometer is 0. Then the bridge is said to be balanced. The balanced Wheatstone bridge is the condition in which the current across this will be equal to 0. So in that particular case, the condition is that P by Q should be equal to R by S, which means this one by this one should be equal to this one. This is kind of symmetry. This is the kind of symmetry we were discussing yesterday, bacho. The kind of symmetry where the ratio of P to Q should be equal to R to S. As we discussed, the resistances should be symmetric about both the initial point and the final point. If they are symmetric about initial and final, then we are done with the problem. Like in this case also, it is symmetric. Like whatever current is flowing through this, so whatever current is flowing through this will come out through this, because this by this ratio will be same as this by this also. You can also write this as P by R will be equal to Q by S. यही रेशियो से ये भी होगा, ठीक है. So that's it. And next there are some little inferences. If P by Q is less than R by S, मतलब R by S, R का वैल्यू ज्यादा है S से और P का वैल्यू कम है Q से, तो करंट will flow from D to B. Oh wait, give me a second. हाँ, तो P is greater, P by Q is less than R by S. P by Q is less than ये, this ratio is less than this. मतलब R का value is very high and S का value is less compared to P by Q. So what will happen here? More current will flow and here more current will flow, which means current will flow from B to D. Okay, I hope you understood this. So the logically what I want to say is current will always try to take the most optimal path where resistance is less, current will try to go there more. Where resistance is more, there less current will go. Understood? So if you say here, suppose P by Q is less than R by S. P by Q is less than R by S. It implies that relatively P has less resistance compared to Q, but R has more resistance compared to S. Na P by Q is less than R by S, मतलब P का वैल्यू सिंपल यार, PS is less than RQ. ऐसे सोच लो, PS is less than RQ. तो इसका मतलब क्या है? पहले जो करंट P से जाएगा वो S से ज्यादा जाएगा. P and S is the most optimal route compared to R and Q, which means effectively current will flow from B to D. Simple. Similarly here, if PS is greater than RQ, this and this are not optimal paths, so more current will flow through this and this. ऐसे सोच सकते, ठीक है. I hope it's clear. Logically भी interpret कर दिए हम already यहाँ पे. So now we are going to do different interpret. So now one more thing. सब लोगों को Wheatstone bridge everyone knows. But what is it in Wheatstone bridge that is more complicated? When I realized it is about how you put the circuit. Wheatstone bridges can be represented in different ways. कुछ भी diagram, कैसे भी diagram है, they can represent a Wheatstone bridge. Okay, जैसे कि यहाँ पे है. If you take all these diagrams, all the 5 diagrams which are shown in this particular diagram, everything is a Wheatstone bridge. Can you believe it? So that is the magic of physics in this particular chapter, guys. कि मतलब यहाँ पे physics equations are simple है. Solving, writing equations is also very simple. Finding symmetry is decent, but तुझे symmetry ढूंढने के लिए you have to the complication of the bridge is what makes it tough for you guys. So I gave you different representations. जब ऐसे सर्क्यूट दिख रहा है और you are asked to find out potential difference across these both, in this type of situation Wheatstone bridge will work. Alright, this is also a Wheatstone bridge setup. So is this, and this. All of these are representations of a Wheatstone bridge. Okay. And everywhere if P by Q is equal to R by S, you can remove T. It's as simple as that. P by R is equal to Q by S, or P by Q is equal to R by S. Hello Bhushan, welcome to the 6th episode of Current Electricity. Must episode होने वाला है. Today we'll have lot of problems discussion on different kinds of loops and Wheatstone bridges and many such topics. Alright, so Kirchhoff's the next law we discussed. This is a Kirchhoff loop law. एक मिनट बीच में ये आ गया. But Kirchhoff's loop law यहाँ पे होना था. So Kirchhoff's loop law यहाँ पे clearly the how to solve this Kirchhoff's loop law problems we can do. We can take a loop and equate to 0. ठीक है, जैसे कि यहाँ पे एक loop है. So I'll write from यहाँ to यहाँ the potential is rising, right? So I will write plus Vs और यहाँ पे current will always flow from higher to lower. I will write here minus I into R1 and यहाँ पे minus I into R2 is equal to 0. Equate loop to 0. Now when there is a multiple circuit like this, there are multiple loops you can use. One, you can take a loop around this. Second, as shown here, you can take this. And third, I will draw. You can take another loop like this. So ऐसे multiple loops we can draw. Understood? Yes, exactly. I will teach star delta today. Though problems in the end of the class, we will have star delta. Definitely good question. Star delta derivation नहीं करूँगा. I will explain the formulas and we are going to do it. Derivation चाहिए तो we can have another special class on derivations of star delta, but वो ज़्यादा use नहीं है करके. I just wrote the formulas. Okay. So yeah, definitely stay tuned. We will have loads of problems along with star delta problems. All right. So yes, this is one simple example I want, मतलब ये hand drawn है, cute लगा तो इस क्वेश्चन को अपना लिया मैं. So the question is find I1, I2 and I3. That's all. It's very simple. इसमें options नहीं है. I will make it. This is a theoretical question I have made. उसको छोड़ के there are a lot of subjective objective problems after this. यहाँ से objective problem start होगा तो पहले थोड़ा theory कर लेते हैं. All right, let's do some theory. So let's call this loop 1. Let's call this loop 1 and we will call this loop 2. And we can also take the entire thing as loop 3, but first let's figure out using loop 1 and loop 2 only. पहले दो लूप में इक्वेशंस लिखो, you will get the answer automatically. तो यहाँ पे क्या दिया हुआ है? By using the direction of current, we can say by using Kirchhoff's junction law. The first equation is by using Kirchhoff's junction law. What is the currents here? यहाँ पे I3 is going to this junction, I2 is also going to the junction, and I1 is coming out of the junction. Right. So from this we can directly say I1 will be equal to I2 plus I3. I will make them all small so that it will be easy for me to write. I1 will be equal to I2 plus I3. ये हो गया first equation हमारा. Now I will start using Kirchhoff's loop law. And I will start analyzing this circuit. The loop laws and these laws are advantages because they can be used to analyze anything. कुछ भी इक्वेशन को तुम एनालाइज करते जाओ, you're done, you're sorted. तो इसमें पहले डायरेक्शन भी ऐसे दे चुके हैं हम. तो let's start from this point, anywhere we'll start from this because it's at the outermost point. We'll start here. तो यहाँ पे पहले क्या हुआ, 10 volts नेगेटिव हुआ. लूप 1 we will solve, -10 और यहाँ पे +10 भी हो गया और यहाँ current is I2 is flowing up, right? So I can write -10 I2 and here current is flowing forward, +20 I3 is equal to 0. This is loop 1. And similarly loop 2, this is how we are rounding it. तो यहाँ पे I'll start from this end again because it's easiest. So +20, यहाँ से यहाँ तक +20 हो गया और यहाँ से यहाँ +10, -10 I2 -5 I1 is equal to 0. यहाँ पे भी एक इक्वेशन. So now we have to simplify both these equations. Let me simplify this loop 1 first. -10 +10 कैंसिल हो गया तो इससे सीधा आ गया हमें यार, I2 is equal to 2 I3. ये आ गया सीधा. This is the second equation we got. Now let's apply this here. So 20 plus 10 30 हो गया. 30 is equal to 10 I2 plus 5 I1. इसको और simplify by 5 कर दो, you will get 6 is equal to 2 I2 plus I1. So this is the third equation. We have everything here guys, we have everything we want here. I1 is equal to I2 plus I3. I'll substitute this 3 in 1 कर दो. 3 in 1. अब 3 in 1 कर दो, क्या होगा? 3 in 1 करने से 6 is equal to 2 I2 plus I2 plus I3. तो हो गया, कितना हुआ ये? 3 I2 plus I3. 6 is equal to 3 I2 plus I3. This is equation 4. Now I will just use 2 and 4. 2 and 4. 2 and 4 से क्या? I2 will be replaced by 2 I1. So I'll get 6 is equal to I2 which is 2 I1. I3 is 2 I2, no? So I'll substitute this 3 I2 plus is it clear guys? Hello Sairam Garu, good evening Amma, welcome to the class. So if you equate equations 2 and 4, so फिर से बता दूंगा, सिंपल है. I2 I3 यहाँ पे है और I1 यहाँ फ्लो हो रहा है, ठीक है. I2 plus I3 is equal to I1. That is the first equation we got. Now looping this equation, we will get +10. We'll take the loop in this direction. So -10 plus 10 minus 10 I2 plus 20 I3. इससे क्या आ गया सीधा? We got I2 is equal to 2 I3. And from this loop, यहाँ पे जो L2 लिखा हुआ है उस लूप से क्या आएगा? We'll start at this point again. +20 plus 10 30 minus 10 I1 minus 5 I2 will be equal to 0. तो ये दोनों इक्वेशन बन गए. Now this equation is send it to the other side, both of these. So we'll get 30 is equal to 10 I2 plus 5 I1. Divide by 5 everywhere. We are getting 6 is equal to 2 I2 plus I1. और we know I2 is equal to 2 I3 also. तो I2 को 2 I3 से सब्स्टिट्यूट कर दो. I2 को 2 I3 से, so पहले 3 in 1 कर दिया है. We did 3 in 1. So using 3 in 1, what will we get? 6i2 i1 इज इक्वल टू i2 प्लस i3, तो इसको ऐसे ही लिख दिया, तो 3i2 प्लस i3 इज इक्वल टू 6 आ गया. दिस इज इक्वेशन 4. नाउ आई एम अप्लाइंग दिस हियर. i2 इज इक्वल टू 2i3. 6 विल बी इक्वल टू i2 कितना है, i2 इज 2i3, 3 इंटू 2i3 प्लस i3 हो गया. तो इससे क्या आया, i3 इज इक्वल टू 6/7 इज डन. आई होप इट्स क्लियर. 18 12 और 6 नहीं है यार, ये मतलब दिस इज 6, i3 is 6/7. This is not a pure question. We will get non-integral solutions because it is a theoretical question. That's why I made this way. और ये डायग्राम भी क्यूट है ना, तो इसलिए डाल दिया. तो i3 आ गया, तो i2 कितना हुआ, इधर डाल सकते हैं. i2 इज इक्वल टू 2i3 विच इज इक्वल टू 12/7 एम्पियर्स. और इन दोनों को i1 में सब्स्टिट्यूट कर दो. i1 इज इक्वल टू by 7. Bhushan, you got it right. Very good. i2 plus i3 is 12 plus 6/7, which is equal to 18/7. There you go. Voila, guys. Awesome solution. Good one, Bhushan. Very good answer. मतलब समझ में आ रहा है. जस्ट इट्स अबाउट राइटिंग इक्वेशंस, नॉट ओनली रेजिस्टेंसेस. मैं बताता हूँ एक सीक्रेट ट्रिक है. एनीवेयर मैकेनिक्स पूरा थर्मोडायनेमिक्स पूरा करंट पूरा एवरीथिंग is about writing two equations. It's about writing three equations. Three equations लिखो, तीन वेरिएबल होंगे, सॉल्व कर दो, हो गई बात. Clear? So that is about it. Now let's go to another question here. This is also another beautiful question. तो यहाँ पे भी सीधा loops दिया हुआ है. So I'm going to solve all the loops again. This time in a different board. Board अलग है. तो ये loop one यहाँ से start करता हूँ. I'll start loop one from here. So it will be loop one. First thing we know. तो इसमें थोड़ा अलग कर दूंगा. लेट मी जस्ट टेक i1 इज गोइंग दिस वे, i2 इज गोइंग दिस वे एंड 3 इज गोइंग दिस वे. जैसे कि डायग्राम दिया हुआ है उसमें 3 कर देते हैं. तो फ्रॉम दिस इक्वेशन व्हाट विल वी गेट, फ्रॉम फर्स्ट फ्रॉम किरचॉफ्स जंक्शन लॉ. किरचॉफ्स जंक्शन लॉ वी गेट i1 प्लस i2 इज इक्वल टू i3. ये हो गया फर्स्ट वाला, because this current is flowing from inside here and resulting is going down like this. Kirchhoff's junction law is this one. Now Kirchhoff's loop law में loop 1 use करूंगा. This time I'll use loop 3. ऐसे ही loop 3 I will use because I didn't use loop 3 in the previous question. I will use loop 3 now. पूरा राउंड कर दो, एक बड़ा सा गोल कर दो. So I'll start from here. I will write plus 10, then I will write minus 10 i1, then I will write plus 20 i2, and then I will write minus 20 is equal to 0. हो गया एक इक्वेशन. इसमें सब जीरोस को निकाल दो, तो व्हाट यू गेट, 2i2 minus i1 is equal to 1. ये आ गया फर्स्ट सेकंड इक्वेशन. रिलेशन में फाउंड आउट. नेक्स्ट आई विल यूज लूप 2. लूप 2 यहां से स्टार्ट करूंगा. इज मेकिंग वन फुल सर्कल प्लस 20 minus 20 i2, और यहाँ पे भी करंट नीचे ले रहे हैं. सो minus 40 i3 is equal to 0. तो इससे क्या आ गया, we'll just divide by 20 everything. We will get 1 is equal to i2 plus 2 i3. This is the third equation. तो हो गया, तीन इक्वेशन आ गए. Wow. And i3 I can write it as i1 plus i2. I will also write i3 as i1 plus i2 here. So applying 3 in 1. 3 in 1 हो गया ना, 3 in 1. So what we get, 1 is equal to i2 plus 2 times i1 plus i2. ये हो गया 1 is equal to 3i2 plus 2i1. और ये 1 कितना आया. Now this is equation 4. Now I will use 4 and 2. 3i2 plus 2i1 is equal to 1. Similarly 2i2 minus i1 is equal to 1. इसको into 2 कर दो. ये i1 कैंसिल हो गई, ये 7 टाइम्स हो गया और यहाँ पे 3 टाइम्स हो गया ना. क्लियर. तो दिस 3i2 plus 2i1 is equal to 3i2 plus 2i1 is equal to 1 एक आ गया. एंड द सेकंड इक्वेशन इज 2i2 minus i1. इसको into 2 कर दिए, तो व्हाट विल आई गेट, 7i2 is equal to 3/7 3, which implies i2 is equal to 3/7. ठीक है, ये आ गया हमें. i2 is equal to 3/7 आया, तो i1 कितना आएगा. तो 2i2 minus i1 is इसमें डाल देंगे सीधे 1 इज इक्वल टू 3 × I2/7 प्लस 2I1, इससे क्या आएगा 2 3 हो गया, तो 2I इज इक्वल टू -2/7 विच इम्प्लाइज I इज इक्वल टू -1/7 एम्स। तो इसका ऊपर वाला इसका डायरेक्शन I माइनस आया, मतलब व्हाट इज द मीनिंग ऑफ इट, I1 is negative implies that the current is flowing in the opposite direction. Clear? I1 is -1/7 amps. And what is the value of I3? I3 will be equal to I1 plus I2, which is equal to 2/7 amps. हो गया? So this is one more way of solving it. We just take different loops and start solving. Okay. तो यहाँ पे एक alternate method ढूंढ लिया मैं. There is another alternate method which is very useful for solving. Okay. The alternate method is, I'll take this as an example. Let's take potential 66, 0, 110 and 88 here. Let's take this to be 0 potential and I'm taking the potential here to be x. तो सीधे यहाँ से equation में क्या लिख दूंगा, I will take this is I1, this is I2 and this is I3. So what is the first equation I will get? The junction law तो हमेशा जारी रहेगा, I1 plus I2 plus I3 is equal to 0. This is first equation we will get. Alright, so I का वैल्यू इसी इक्वेशन से पूरा सॉल्व कर देंगे. लेट्स solve the entire thing by using this single equation. तो इससे I will just draw potential from here to here and I will say that is equal to x. So what will I say? 66 minus 5I1 is the value of potential here, is equal to 110, which is also equal to 88 minus 10I3. ये एक इक्वेशन बन गया. दिस इज ऑल्सो द सेकेंड इक्वेशन. तो इससे सीधा हम पहले इसको सॉल्व कर लेंगे तो I3 आ जाएगा. तो व्हाट डू वी गेट फ्रॉम दिस? 10I3 इज इक्वल टू minus 88 minus 110. तो इससे क्या आएगा? I3 इज इक्वल टू -2.2 एम्पियर्स. हो गया, सीधा एक आंसर आ गया. सिमिलरली विल इक्वेट दिस बोथ. 66 minus 5I1 is equal to 110, मतलब 5I1 is equal to -44, which implies I1 is equal to -8.8 amps. Yes, this is kind of nodal analysis only, but we are doing nodal analysis for complex circuits. ठीक है? When there are multiple loops, we will use nodal analysis also. हाँ, इसको nodal analysis बोलते हैं. वर्ड में भूल गया. Alternate method for loop law is nodal analysis. बस. So I2 will be how much? I2 will be equal to 11 amperes. तो यहाँ 11 एम्पियर से ये दोनों माइनस माइनस है, मतलब करंट यहाँ से 11 जा रहा है, इस साइड 8.8 जा रहा है और इस साइड 0.2 एम्पियर्स जा रहा है. So that is one more method. So now another interesting topic here. All right. तो इस टाइप का सिचुएशन है तो क्या होगा when two circuits are independent to each other and they are following this loop. ठीक है, इस टाइप का सिचुएशन में हम क्या करेंगे? तो वन थिंग यू हैव टू अंडरस्टैंड हियर. अरे यहाँ पे ए और डी है ही नहीं. चलो कुछ पॉइंट्स लिख देते हैं. ये ए है, ये बी है, ये सी है, ये डी है, ये समथिंग लाइक दैट. सो वी ए माइनस वी डी, मतलब कुछ ले लिए, कुछ ऐसे ही कुछ पॉइंट्स. So we'll analyze this circuit first. Okay, we'll analyze the circuit and then go to the next topic. Great job. Any doubt you have, just feel free to drop in any comment, anything you want, just feel free to drop in into the comment section below. And don't forget guys to like and share this video because we are going to have awesome techniques. यहाँ पे बस पूरा बेसिक्स चलेंगे, बेसिक से चलेंगे. ठीक है, इसमें ये एक लूप इमेजिन कर लो, यहाँ पे एक और लूप इमेजिन कर लो. Always the potential should remain zero and the current here and here will be same. So by logic, one thing we know is, देखो यहाँ पे करंट कितना है? The current in loop 1, I'll call this loop 1, I'll call this loop 2. In loop 1, we can say 10 minus 2 into I1 minus 3 into I1 is equal to 0. तो इससे सीधा आ गया I1 is equal to 2 amperes. What about in loop 2? देखोगे 20. ऐसे घूमोगे ना तो स्टार्ट फ्रॉम हियर प्लस 20 माइनस 6I2 माइनस 4I2 इज इक्वल टू 0. इससे क्या आ जाएगा? I2 इज ऑल्सो इक्वल टू 2 एम्पियर्स. यहाँ पे भी 2 एम्पियर से, यहाँ पे भी 2 एम्पियर से. एंड वन मोर थिंग वी नो, द करंट विच इज फ्लोइंग फ्रॉम दिस एंड टू दिस एंड विल बी दिस. यहाँ पे 2 एम्पियर फ्लो हो रहा है, यहाँ पे 2 एम्पियर फ्लो हो रहा है. तो व्हाट इज द करंट थ्रू दिस साइड? So when there is only two connections connected by random terminals, यहाँ पे current will always be equal to 0. When two points, two random points are connected, V difference will be 0. There will be no current much. There will be no current initially. तो मतलब कोई सा random सा 2 points ले लिए तो that time there won't be any current which is flowing through that. So if you call this point A and this point D, VA minus VD will be equal to 1 volt. That's all. और current flow नहीं हो रहा है. It's a dead end. It's a, just a road. It's a road which is having an incline time. All right. Okay. So now we are into the theoretical part, guys. आप solve करना शुरू करो. I will also give you time now. Just give me one moment. I will search for the EP करते हैं. So I'm going to have a timer from now. Let's see how many of you guys can solve it. I'm going to give 1 minute, guys. एक बार आराम से करो इसको. 1 minute देता हूँ मैं. The ratio of currents through A, B, and through FA, EB, and DC in magnitude. What is the magnitude or what is the ratio of currents flowing through all the three given the circuit? एक बात तो हम हमेशा याद रख सकते हैं, ठीक है, कि इसमें मान लो यहाँ लूप कुछ ऐसे ले लिए. Let's take one loop one like this, L1, and let's take another loop like this, L2, and let's take the current here to be if the current here is ऐसा जा रहा है ना, तो यहाँ पे I1 ऐसे ले लेते हैं, यहाँ पे I2, let's take I2 is going like this. So everywhere let's take I1 is flowing in this direction and I2 is flowing in this direction and I3 is flowing. Let's take symmetry for simplicity. Let's take सब बाहर जा रहे करके ले लो, I1 I2 I3. ठीक है. One thing we know for sure, ratio of I1 plus I2 plus I3 will be equal to 0. ये बात पता है. ठीक है. The ratio I1 and plus I2 plus I3 is always 0. This is the first condition. And then इस loop में लग जाओ, loop 1 में लग जाओ. This is loop 1. और loop 1 देखा जाए तो यहाँ से E से स्टार्ट करेंगे. It will be plus 10 plus I1 plus 30 plus 2I3 is equal to 0. इससे क्या आ गया? I1 plus 2I3 plus 40 is equal to 0. ये हो गया सेकेंड इक्वेशन. और लूप 2 ले लो. अब लूप 2 में C से स्टार्ट करेंगे. सो इट विल बी -20I2 प्लस 50 माइनस ये 2 है -2I1 माइनस 30 इज इक्वल टू 0. तो इससे क्या हो गया? सिंपल I1 प्लस I2 इज इक्वल टू 10. एक आ गया हमें फ्रॉम दिस इक्वेशन. वी गॉट एन इक्वेशन सेइंग I1 प्लस I2 इज इक्वल टू 10. तो I1 प्लस I2 10 है, तो I3 कितना हुआ? अरे ये I3 है ना, विल बी I3 -2I2 माइनस प्लस 50 -2I3 हो गया ये, -30 इज इक्वल टू 0. तो I1 प्लस I3 हो जाएगा 30, I2 प्लस I3 सॉरी. तो I2 प्लस I3 हो गया 10. तो इसका मतलब क्या है? I1 विल बी इक्वल टू 10 -10 इन दिस केस. क्लियर? तो यहाँ से करंट इस साइड इस डायरेक्शन में फ्लो होगा. सो इफ यू सी केयरफुली, द करंट ऑफ I1 इज -10 नाउ. हाउ इज दिस पॉसिबल? I3 बहुत ज्यादा भी हो सकता है. तो I1 विल बी इक्वल टू -10। पहले ये तो आ गया, तो यहाँ पे फ्लो कितना है, I1 यहाँ पे 10 एम्पियर्स करके हमें एक वैल्यू आ गया। Alright, we got a one value of I1 is equal to -10 here, and if you look into this loop here, इससे क्या होगा, we can substitute this in this now. I2 also is done, so I'll just substitute this into 2 में substitute किया, -10 plus 2I3 plus 40 is equal to 0, तो इससे क्या आ गया, I3 is equal to -15। I3 का वैल्यू कितना हुआ, -15। तो I3 का वैल्यू भी -15, मतलब यहाँ पे भी करंट है 15 में करके फ्लो हो रहा है, यहाँ पे 10 है, यहाँ पे 15 है, और यहाँ पे 25 हो जाएगा। तो मिस्टेक हुआ है यहाँ पे, देयर इज सम इश्यू विद द, हाँ पर देखते हैं, लेट्स सी। यहाँ पे करंट 25 एम्पियर्स हो गया, यहाँ पे 13 हो गया, और यहाँ पे अच्छा हो गया सही में। तो इसमें I1 is to I2 इस तरह I3 कितना हुआ, ये I1 is 10, I2 is 25 and I3 is 10, 15, यहाँ पे 15 है, तो I1 is this, I2 is this one, no, I2 is this one which is 25 and I3 is 15। तो इसको थोड़ा नोडल एनालिसिस में एकदम रेशियोज में डाल दिए, तो यहाँ पे 10 है, 15 है, 25 है, द रेशियो इज सी। आई होप दिस इज क्लियर गाइस, सब क्लियर है ना। सो जस्ट टेक ईच इंडिविजुअल करंट्स एंड यूज नोडल एनालिसिस, यू विल गेट द ratios right. All right, the find the current through the 6 ohm resistance, this is also another awesome question। तो इसको अगर हम देखें, इस नोडल एनालिसिस कर लो, इसका भी नोडल एनालिसिस कर लो, ऐसे करके लेट्स टेक I1 is flowing in this direction and I2 is flowing in this direction। तो ऐसे ऐसे करके I2 हो गया, तो ये कितना होगा, ये I3 अगर मान लिए, तो यू विल गेट I1 plus I3 is equal to I2। दिस इज द फर्स्ट इक्वेशन वी विल गेट based on this, and you start solving from point B in this full circle। So from this point B in loop 1, I'll call this loop 1, I'll call this loop 2। तो loop 1 का क्या इक्वेशन है, तो loop 1 का इक्वेशन है -6I1, क्योंकि यहाँ नेगेटिव है, प्लस 12V एंड प्लस 12I3 इज इक्वल टू 0। इसको डिवाइड बाई 6 कर दो, क्या होगा, I1 इज इक्वल टू 2 प्लस I3। दिस इज द फर्स्ट इक्वेशन। सिमिलरली इफ आई यूज लूप 2 हियर, I will get the similar equation again। I will get I2, I will get this thing, current is flowing ulta, no, so plus 12I3 minus 6I2 plus 12 is equal to 0। इसको भी सिंप्लीफाई कर दो, you will get I2 is equal to 2 plus I3। तो इससे क्या आ जाएगा, I1 is equal to I2। if I1 is equal to I2, I3 will be how much, 0। तो इस क्वेश्चन में सिंपल हो गया, I3 0 हो गया, I1 will be equal to I2 will be equal to 2 amperes। Simple solution to this। All right, so इसमें this is one more very nice question। It's a very simple question। What is the resistance which should be connected parallel to the 10 ohm resistance such that the potential at B and D become equal। तो ये बैलेंस व्हीटस्टोन ब्रिज होने के लिए what should the value parallel to this be। इसको लिए 1 मिनट दे रहा हूँ मैं, टाइम स्टार्ट करता हूँ। If you get this right, it's a very simple question। हम पहले सिंपल क्वेश्चंस करेंगे, बट we'll do lots of questions which apply the question, the Wheatstone bridge and the nodal analysis in different methods। तब हर जगह एप्लीकेशन डिफरेंट है। इसमें देखते हैं, how many of you can get it right। What should be the resistance connected to the 10 ohm such that the potential at B and D become same। तो इसमें 10 ohm को पैरेलली एक और रेजिस्टेंस देना है। That resistance will make sure that this whole situation becomes a balanced Wheatstone bridge। Yes भूषण, गुड आंसर, सिंपल है पर सही है, वेरी गुड। तो इसमें क्या है, दिस शुड बी R1 by R2, so P by Q should be equal to R by S। The condition for, let's call this P, Q, R and S। The condition Wheatstone bridge is P by Q should be equal to R by S, which implies 20 by 20 will be equal to R equivalent of B by 5. तो इससे क्या आ जाएगा? R equivalent at B is equal to 5, and 1 by 10 plus 1 by x should be equal to 1 by 5, which implies x is 1 by 5. There you go. Great solution. Good one, Sim24. Welcome. Okay. Now next thing is find the current through the 4-volt battery. इसमें भी 4-volt बैटरी मतलब ये बैटरी ले लो. टेक दिस बैटरी, राइट. तो इसमें कैसे सॉल्व होंगे? टेक दिस लूप फर्स्ट. Current flowing through this I1 will be how much? 2 by 5. And current flowing in this loop, I2 is equal to 4 by 8, which is equal to 0.5. This is 0.2. So one thing we know, the loop, in this loop the current is 0.2 or 0.5 amperes, and in this loop it is 0.4 amperes. But what about the current flowing through this? Again, as we discussed below, it will have no reading, so answer will be B. इसमें कोई कैलकुलेट करने का जरूरत भी नहीं, ऐसे ही कैलकुलेट किया so that you can get used to calculation, but then there is no need of कैलकुलेशन हियर. ठीक है, इसमें जीरो आंसर सीधा लिख दो. अगर तुझे कुछ और एप्लीकेशंस करना है इसका, वी विल डू देम एज वी गो फॉरवर्ड गाइस. तो दिस इज अनदर कॉम्प्लिकेटेड सर्किट. ये मैं तुम्हें होमवर्क की तरह दे दूंगा. आई वांट यू गाइस टू फाइंड आउट I1, I2, I3 in this particular situation. ठीक है. So yes, this is for Bhushan Bhatye. So this is delta to star and star to delta conversion guys. मतलब ये बहुत complicated equations जहाँ पे symmetry नहीं है. We are going to okay, I'll explain this. Explain the previous one again. यहाँ पे is this one what you want me to explain or this one? Alright, so ठीक है. That is the definitely guys. थोड़ा एक बार explanation जो जिसके चाहिए just let me know so that we can discuss that again. Delta to star transformation resistance conversion formula. Yellow one, you mean this one? सिंपल है. इसमें करंट कितना है इस लूप को देख लो. Let's take this loop alone. Let's take just this loop. इस लूप देखा जाए तो the current flowing in this loop will be equal to 0.4 amperes. Similarly, current flowing through this, if you take this loop like this, you can say 4 plus minus 3I1 minus 5I1 is equal to 0. तो इससे सीधा यहाँ पे 4 by 8 आ जाएगा. यहाँ पे 0.5 amps आएगा, यहाँ पे 0.4 आएगा. But all of them are in their own loops, right? They are in their own loops and this is not a part of any loop. तो यहाँ पे सीधा directly I will be equal to 0. Got it? Because they are not connected to each other by any logic. The moment we find some logic there, we will definitely use it. Okay, all right. So now delta to star conversion, this is very important for those guys who have trouble finding symmetry. When there are 3 junctions, ये बहुत load हो जाता है, तो उसको simplify करने के लिए we are going to convert this into this. So मगर some imagine there is RA, RB and RC are 3 formulas. RA, RB and RC are 3 resistances. So these can be converted to this. As 1, 2 and 3. ठीक है. So इसमें this can be converted into 3 resistances which will have the same effect of this 3. तो इसको R1 कर दिए, इसको R2 कर दिए, इसको R3 कर दिए. The relation between resistance R1, R2, R3 and the base resistance is this. Understood? So this is the relation between all the 3 resistances. तो R1 जो है इसके एडजेसेंट जो भी रेजिस्टेंसेस है उनका मल्टीप्लिकेशन रख दो. यहाँ पे RC था, यहाँ पे RB था, तो R1 will be adjacent sides multiplication by sum of all sides. It's also nothing but product of added it is nothing but the product which is pi adjacent resistances by sum of all resistances. तो ये formula इसके लिए it is nothing but the product of adjacent divided by sum of all resistances in a triangular delta star conversion. ऑलराइट, सॉरी, डेल्टा स्टार कन्वर्जन में ये होता है, तो R1 का वैल्यू हो जाएगा, R1 is from the top, right? So adjacent two sides are RB and RC. You will get RB RC by RA plus RB plus RC. Similarly, R2 जो है, it is beside RC and RA. So R2 will be RA RC by, no, derivation is not required for JEE, man. अगर चाहिए तो definitely we will look into it, but it's not there. There is no derivation for this. तो इसमें प्रॉब्लम सीधा जंप करते हैं. एंड सिमिलरली R3 ऑन द अदर साइड इज बिसाइड द एडजेसेंट साइड्स ऑफ R3 आर A and B. ये हो गया RA RB by RA plus RB plus RC. It has a very simple derivation also, but we don't have time right now to derive it, so I am not deriving it. We can have a special class on derivation only. Alright, क्योंकि वो लगेगा 20 मिनट. तो एक सिंपल क्वेश्चन है, ये व्हीटस्टोन ब्रिज है कि नहीं, है कि नहीं, है कि नहीं. इज दिस ए व्हीटस्टोन ब्रिज गाइस? नहीं है, सिंपल, बिकॉज across C and D, if you observe across C and D, this by this is not equal to this by this. So this is not Wheatstone bridge. So if it's not a Wheatstone bridge, it becomes very complicated, right? Calculation. तो इसको मैं simplify कर दूंगा. What I will do is I will take this junction here. This looks like a triangle junction. A B C D E F. Triangle CEF will become is now equal to delta CEF. ऑलराइट, तो ये इसको हम ऐसे कन्वर्ट कर देंगे. वी विल फाइंड आउट रेजिस्टेंसेस हियर, हियर एंड ऑलराइट, तब सिंप्लीफाई हो जाएगा. सो लेट्स कॉल दिस, यहाँ पे रेजिस्टेंस, यहाँ पे रेजिस्टेंस और यहाँ पे रेजिस्टेंस. ऑलराइट, so we'll call this 1, we'll call this 2, we'll call this 3. So what is the value of R1? It will be product of adjacent by sum of everything. Product of adjacent is 40 into 60 by sum of adjacent is 40 plus 60 plus 100 is equal to 200. So इसका हो गया 12 ohms. Similarly R2, which is this, will be equal to 40 into 100 by 200, which is equal to 20 ohms, and RC is equal to, RC will be adjacent, this is 3, right? R3. R3 will be equal to adjacent sides between them are 60 and 100. 60 into 100 by 30. So now we found out all the three resistances here. Now we can simplify this into this diagram. 12, 20, 30, 100 और 90. So if you add these both here, ये दोनों का 120 हो गया, resistance ये दोनों का 120 हो गया, but the whole thing will become 60. The effective resistance will be 12 plus 60, which is equal to 72 ohms, guys. Yes, very good. Good job. 12, 20 and 30. So the effective is 72, and the total, so that is only the answer, which is option C. Great job, guys. This is the circuit analysis of star delta. This is a simple method. So generally when there is complex situation like this, we can simplify it. ठीक है. सिमिलरली स्टार टू डेल्टा कन्वर्जन में रेजिस्टेंस फॉर्मूला क्या होगा, उसका एकदम उल्टा हो जाएगा. ठीक है, उसमें ऊपर 2 को मल्टीप्लाई किया और नीचे सबको ऐड कर दी. इसमें ऊपर सबको 2 मल्टीप्लाई कर दो, नीचे 1 को ऐड कर दो. ठीक है. सो वॉट एवर इट इज, दिस इज अ वेरी सिंपलर एक्सप्लेनेशन फॉर दिस विल बी, या जो R1 है उसके एग्जैक्टली ऑपोजिट वाला रेजिस्टेंस होगा. RA विल बी इक्वल टू इंडिविजुअल मल्टीप्लिकेशंस बाय ऑपोजिट रेजिस्टेंस. सिंपल टॉपिक है. R from delta to triangle will be that R will be R1, RA will be equal to summation of Ri Rj by R opposite. This is the standard formula which we can apply everywhere. It is summation of Ra Rj, all summations R1 R2 plus R2 R3 plus R1 R3 divided by the opposite resistance. अंडरस्टूड. तो यहाँ पे RA अगर मान लेते हैं, ये हो जाएगा R1 R2 plus R2 R3 plus R3 R2 by opposite resistance which is R1. Clear? Similarly RB will have the same concept. RB के opposite क्या है, R2 है. समेशन कर दो, R2 को नीचे डिनोमिनेटर में डाल दो. एंड सिमिलरली RC के सामने क्या है, के सामने वाले को डिनोमिनेटर में डाल दो। आरसी के सामने R3 है, R3 को डिनोमिनेटर में डाल दो और R1 R2 प्लस R1 R3 प्लस R2 R3, star to delta conversion. So whenever you are stuck in a star, you can become a delta. This is how you get it. Alright, delta to star यहाँ पे है। यहाँ पे देखो, इसमें स्टार को डेल्टा में कन्वर्ट कर देंगे। लेट्स सी इफ इट विल वर्क। ऑलराइट, तो यहाँ पे we can do it in multiple methods. So one thing I'll do is I will convert this star into a delta. इस स्टार को मैं ऐसे करके सॉल्व कर दूंगा। आई थिंक वी विल गेट सिंपलर सॉल्यूशन। ऑलराइट, तो इसको ऐसे करके सॉल्व कर सकते हैं। And all of them are equal, as in this particular situation, R1, this 1 ohm, RC के सामने B है। Yes, nice one, Sim24. Very good. Nice spontaneity. Didn't know you had this much spontaneity, man. So this is one resistance, this is one resistance, and this is one resistance. I'll convert it this way. अब ये क्या हो जाएगा? Each individual resistance will be R1 R2 plus R2 R3 plus R3 R1 by सामने वाला. So everything will become 3 ohms. 3 ohm, 3 ohm. So now this is 3, this is 3. If you observe carefully, there is 1 ohm here. This will be 3 ohms. Now this is 3 followed by another 3 here. Right? So from this both you can say this one will become 3 by 2. और ये 3 हो गया। इसके बीच में यहाँ पे क्या है? यहाँ पे 1 एक है और यहाँ पे 1 एक है, फॉलोड बाय यहाँ पे 0.5 और फिर यहाँ पे 0.5 and 3 ohms यहाँ पे। So now we have another triangle here. We have another triangle here. I will convert this again into another delta. Okay. Triangle को delta में convert करना है, तो this one what I will do is I will convert this triangle to delta now. Alright, I will convert this triangle to delta. So this triangle I will convert to delta. How will this triangle become delta? यहाँ एक resistance, यहाँ एक resistance और यहाँ एक resistance. बढ़िया, एकदम बढ़िया। तो ये क्या हो गया? यहाँ पे पहले 3 था, 3/2 था, ये भी 3 था और ये 1 1 और 0.5, ये दिस इज 1 1 एंड 0.5। तो इसमें दिस रेजिस्टेंस विल बिकम R1 R2 प्लस R2 R3 प्लस R3 R1। वो समेशन देख लो, R1 R2 R2 R3 प्लस R3 R1, summation of Ri Rj is coming out to be 2. So I will write off this value is equal to, तो यहाँ पे 2/0.5 हो गया, तो यहाँ पे 4 ohms हो गया, यहाँ पे 2 by इसको यहाँ पे एक रेजिस्टेंस डाल दिए, यहाँ पे एक रेजिस्टेंस डाल दिए, यहाँ पे एक रेजिस्टेंस डाल। So if you look at this carefully, this is how it will look. No, 0.5 यहाँ पे है, 1 यहाँ पे, 1 यहाँ पे. So you can convert this into this. उसमें ऐसे ऐसे और ऐसे ऐसे और ऐसे कन्वर्ट हो जाएगा, राइट? दिस इज हाउ दिस विल गेट कन्वर्टेड, गेटिंग इट? सो इसका रेजिस्टेंस कितना हुआ? 4 हो गया और इसका सामने वाला क्या है? 1 है, तो दिस विल बिकम 2 ohms और फिर से इसके सामने वाला भी 1 है, तो दिस विल आल्सो बिकम 2। तो ऐसे हो गया। यस, वेरी गुड, दैट इज आई थिंक द राइट आंसर। तो वी हैव टू सॉल्व दिस होल थिंग, इट इज अ लिटिल लेंथी। यहाँ पे 3 है और यहाँ पे 0.5 भी बचा है, तो इसको आप सिंप्लीफाई कर दो। 1/3 1/4 में सॉल्व करने से ये क्या होगा? यार ये बहुत लेंथी हो रहा है, इसको एक और सिंप्लीफाइड मेथड सॉल्व करेंगे। लेट्स सिंप्लीफाई इट फर्दर, इट विल बिकम वेरी सिंपल। यहाँ पे 3 है, यहाँ पे 3/2 है, यहाँ पे 3 है, यहाँ पे 1 है, यहाँ पे 0.5 है और यहाँ पे 1 है, यहाँ पे 3 है और यहाँ पे 0.5 है। Alright, so this is what we can simplify. Simply join these both and get a 1 here, man. That is all. हो गई बात। 3 1 1 1 3 3 3 3/2, ये सिमेट्री बहुत ज़्यादा दिख रहा है हमें, तो इसमें सिमेट्री से क्या होगा? यहाँ पे 3/2 है, यहाँ पे 3 है, यहाँ पे 3 है, तो लेट्स Natural treasure. So yeah, welcome to this. B is the right answer for sure, but इसको थोड़ा simplify करने में मैं it's getting lengthier when you simplify this. तो कोई नहीं, यहाँ पे 1 ohm हो गया. So let's not simplify this here. We are going to simplify till now. अभी तक तो हो गया. यहाँ पे 1 1 और यहाँ पे भी 1 हो गया. So if you observe, this is symmetry here. 3 1 here and 3 1 here. This is not there, no. This is not there. हाँ है, यहाँ पे 3 है. यहाँ पे 3 1 है, 3 1 है. तो यहाँ से ये जो है सिमेट्री में दिख रहा है. ऑलराइट. यहाँ से जो करंट जाएगा वहाँ यही जाएगा. यहाँ से जो करंट जाएगा, सेम करंट विल फ्लो थ्रू दिस and this. Right, same current is flowing through this and this, which means we can neglect of this circuit totally. ऐसे भी कर सकते हैं by symmetry, but no, we will only use star delta formations now. I will convert this star into delta. ठीक है, यहाँ पे जो स्टार है, यहाँ पे 3 था, यहाँ पे 1 है और यहाँ पे 1 है. ठीक है, 3 1 and 1 are given, right? If you observe carefully, we got of this delta here. तो यहाँ पे 3 है, यहाँ पे 1 है, यहाँ पे 1 है, यहाँ पे 1 है. Got it? So I will convert this triangle, this whole thing, into delta. तब everything will get simplified. इसको मैं स्टार में कन्वर्ट कर दूंगा. डेल्टा टू स्टार कन्वर्जन क्या है? स्टार टू डेल्टा कन्वर्जन यहाँ पे है. डेल्टा टू स्टार में यू हैव टू जस्ट मल्टीप्लाई एडजेसेंट्स एंड डिवाइड बाय द सम. तो यहाँ पे ऐसे करके सॉल्व कर दूंगा. सो व्हाट विल आई गेट? यहाँ पे 3 हो जाएगा, यहाँ पे 3/2 हो जाएगा, और यहाँ पे एडजेसेंट मल्टीप्लिकेशन बाय सम ऑफ ऑल 3. तो यहाँ पे 3/5 हो गया, यहाँ पे 1/5 हो गया, और यहाँ पे 1/5 हो गया, followed by 3 here and 1 here. So this is the solution. एकदम सिंपल हो जाएगा इसके बाद. ऑलराइट, तो यहाँ पे 3 है, यहाँ पे 3/2 प्लस 1.5 हो गया 1.7, और यहाँ पर 0.6 हो गया. यहाँ पे 1 प्लस 1.5 इज 1.2, एंड यहाँ दिस इज इक्वल टू 3 अगेन. तो अगेन विल अप्लाई अनदर स्टार डेल्टा. तो थोड़ा लेंथी है, तो इसका आंसर है 8 volts. ऑलराइट. Now, so before we go further, crack IIT-JEE. Let's talk a little about IIT-JEE. Crack IIT-JEE with India's largest platform, which is Unacademy, for sure. To get the Plus subscription to access unlimited live and recorded courses from India's best educators. Get the subscription using the code NSS1, guys. Make this viral. Okay. Plus subscription क्या मिलेगा? What do you get with Plus subscription? You get daily live classes where you can chat with your educators, engage in discussions, ask your doubts and questions, and answer polls all where the class is going on. You have dynamic doubt session where you can send your doubts. You can send your doubts, any question you have, to the teacher, and the teacher can discuss that in class. All which is happening dynamically. यहाँ पे that is the major issue we have here. So any doubts you have, you can discuss them in the Plus subscription. So you get access to the best of Unacademy there. Understood? So best of Unacademy वही है. You get daily live classes. All polls भी रहेंगे. You will have live tests and quizzes. One of those quizzes is conducted by me. It's called the daily quiz show. It happens at 10:30 p.m. every day. So stay tuned for that quiz show. Definitely join us there. All right. So one more thing, live tests and quizzes. Evaluate your preparation with regular mock tests and quizzes. You can evaluate your preparation with regular mock tests and quizzes. And like I say, a quiz a day will keep you ready for JEE any day. So that is what we have to do here. All right. And you will get live tests and quizzes there. You'll have structured courses where every course, every topic is put in a detailed structure. Like कुछ भी topic तुम miss किए college में, you can go to the course there and you can read the entire course. You can study. You'll have quizzes. Everything will be available there. You can follow those courses and help you prepare for your exam. All right. And not only this, you have unlimited access to all the teachers who teach in the Plus course. Every recorded course and every live class by all teachers present in the app will be given to you. Now that is awesome deal. Like Joker says, when you're good at something, you never do it for free. So Unacademy is charging a nominal fee of 38,500 for 1 year. ये दिखने में अगर बड़ा भी लग सकता है, तो EMI ऑप्शन भी है उसमें for you to take it. So 38,500 for 1 year. All right, and it also costs 28,000 for 6 months. 38.5k for 1 year and 28,000 for 6 months. Not only that, you can use the code NSS1 to get extra 10% off. This is what I've been telling you about, guys. Use this code NSS1 to get extra 10% off, and ये हो जाएगा 35k for less than 35k for 1 year. Now this might sound little, might look big, but if you cut it on a daily basis, it's 32 rupees per day on physics, chemistry, and mathematics. Understood? It's only 32 rupees. Come on, that's awesome. तो 2 साल के लिए अगर चाहिए तो 2 साल का प्राइस होगा 56k for 2 years. Use the code NSS1, you will get it for 50k. You'll get it for 50k. This is coming out to 23 rupees per day. So awesome deals here, guys. It's at Unacademy. It is very cheap. So awesome. Now next for the Iconic subscription. Iconic subscription is for those guys who need an extra mentor. जिसको mentor की ज़रूरत होती है. But they will be given a personal coach who will help you with your guidance based on your performance, your in-depth test analysis, and you'll also be given a study planner with which you can follow preparing for JEE while at home. Not only this, you also get all benefits of less along with this. The cost of this is 56k for 1 year. इसको NSS1 कोड यूज करते ही ये 50,000 हो जाएगा, which is 46 rupees per day. And ये 2 year का कोर्स 86k है, जिसमें कोड यूज करो NSS1, you will get it for 77,400. This is coming out to 32 rupees per day on physics, chemistry, and maths plus mentor. So awesome deals here, guys. So if you are interested in taking it, this is for those guys who are preparing for JEE 2022. ठीक है, तो you can go for it. नहीं तो अगर तुझे YouTube पे ही देखना है तो YouTube is always there for you. Okay, next. All right, guys. So next is a concept called branch manipulation. बहुत intuitive topic है, but then just so you can remember, this is also a trick. ये एक मस्त trick है. What is branch manipulation? In a branch of an electric circuit, the position of components in series can be interchanged without any effect to the parameters of the circuit. मतलब यहाँ पे ऐसा है, so this can be interchanged. Like I can put 5 ohm resistance and 3 ohm resistance along with 12 volts. These both are still same. And I can also put 12 ohms here, 5 ohms here, 3 ohms here. This will still be same. I can also put 5 ohm like this, 3 ohms here and 5 ohm here. It will still be same. Getting it? So all of these together are same circuit. They form the same circuit because they represent the same equivalent. This across end A and B, the equivalent resistance is 8 ohms and the equivalent potential difference is 12 volts. So वो तो बदल नहीं रहा है, right? That is not changing. So we can say that you can manipulate it. You can shift all series resistances or voltages, potential batteries or charge or capacitors or inductors, कुछ भी you can shift them along the line. All right. तो एक simple example करते हैं इसमें. Find the current in this given circuit. So what I will do is I'll send everything, all the resistance to one side and all the capacitor potential differences to one side. So this will be equivalent to, I'll send everything to the top. 10 volts यहाँ पे, और इसका डायमेंशन ऐसे ही होगा, 20 वोल्ट यहाँ पे लिख दो और यहाँ पे लिख दो 3, 4 and 8. तो क्या हो गया, इक्विवेलेंट कैसा हो गया, ये 30 वोल्ट्स और 15 एम्पियर्स हो गया, 15 ओम्स हो गया, ये 30 वोल्ट्स हो गया. तो I will be equal to 2 amperes. So is this clear, guys? So मतलब एकदम you can shift everything around. ये बहुत easy question है और इसका solution भी है. Okay, for a group of cells we can, the next thing we do is we are going to discuss about grouping of cells. So cells and resistances दोनों को मिलके group करेंगे. Very good, Sim24, great job. थोड़ा tired लग रहा है. के बाद we will call it off. Grouping of cells. For a group of cells, we can replace set of cells by single equivalent cell having same potential difference and internal resistance as the combination of set of cells. This is grouping. Grouping is just grouping. अभी तक grouping हम resistances का देखे हैं, capacitance का भी we discussed. Hello Ankita, good evening. You come little late. We are almost at the end of the topic, but we are starting grouping of cells. So we will discuss a little about this today. Problems तो सब हो गए. We did lots of problems. All right. So the main thing is grouping of cells में we can replace any set. We discuss this for capacitances, we discuss this for resistances, equivalent resistance और equivalent capacitance बोलते हैं. तो इसमें भी grouping में equivalent potential difference and equivalent internal resistance भी होंगे. We will discuss about those things today. So there are multiple different ways of taking it. One is series combination, one is parallel, और combination of them जिसको हम battery भी बोलते हैं और ये circuit भी बोलते हैं इसको. So you can take combination of them. Grid, this is nothing but a grid. There are three ways of looking into it, so let's look at them one by one. The first, combination of cells in series. When cells are connected in series, the total EMF क्या होगा? यहाँ पे जो EMF है, यहाँ से तो just imagine like you are crossing a river, like we discussed the original case. तो यहाँ पे E1 के कारण बढ़ेगा, E2 के कारण भी बढ़ेगा, E3 के कारण भी the potential difference will keep increasing across the entire this thing, if you observe, right? So the total EMF effective can be represented as sum of individual EMFs, E2 plus and so on. So if you have doubts in HCV, how can you get them clarified? Well, one thing I want to, we can have a doubt session in the app. Install the Unacademy app and get to the app right away. I will have a special class for you on doubts. Any doubts you have, we can discuss them there. All right. So you can send all the questions to me directly on the app. Search for my name N Srikant on the app. मेरा नाम N Srikant है. Search कर लो, उसको subscribe कर लो मुझे. So whenever I have a class, we can have doubts there. All right. Any kinds of doubts will be clarified in that particular place. Telegram. चलो आज कर दूंगा. Today, by the time we get to the app, we will have Telegram ready. All right. I will look into the Telegram thing. I will install it on my phone right now. Okay. Thank you for reminding me. Sim24. You keep reminding me. This is the second time you did. Funny way also, but then I keep forgetting. All right. So इसमें effective EMF कितना होगा? As we discussed, everywhere there will be built-in potential, right? There will be potential built from यहाँ से यहाँ अगर जाओगे तो potential build हो रहा है. यहाँ थोड़ा घटेगा, but then again there will build again, like as we saw in the beginning. So EMF total will be sum of all individual EMFs, and resistance be everywhere the same current will flow through all the resistances. So R equivalent will also be equal to sum of individual resistance. तो अब इस टाइप के सिचुएशन में what will the total current be? Total current will be E net by R net, which will be equal to summation of EI's. E net मतलब कितना है? Summation of EI by summation of RI plus R. Understood? Now इसमें अगर generally when there are multiple such resistances placed, तो थोड़ा identical भी हो जाएंगे because symmetry लगाना चाहिए. So when symmetry is used, we can use this concept. When n cells are used and identical cells are used in series, you will get current will be Ne by N R plus Kepler. When R is the equivalent resistance, internal resistance of the battery having potential difference. And if NR is much greater than R, we will get I is approximately equal to E by R. So current from one cell. And if NR is much less than Kepler, we will get I will be equal to Ne by. Understood? Which can also be written as n times the current from n cells. So series में generally a बहुत बड़ा resistance के across है. So the more cells you put, more current you will. Okay, अब ये parallel combination है. So parallel combination when cells are connected in parallel, the total EMF of parallel combination remains equal to the EMF of single cell. Okay, एक EMF सब everywhere the EMF of single cell will remain same. Across इसका जो EMF है, इसका EMF भी सेम रहेगा. ठीक है. तो मान लो यहाँ पे I1 करंट फ्लो कर रहा है, तो इसमें थोड़ा और डिराइव करेंगे. I will derive the. तो इसका थोड़ा derivation करते हैं. Let's take two different resistances. Okay, when two of them are in parallel. E1 R1 लिख दो, E2 का R2 लिख देंगे. All right. So इसमें when E1 and R1, E2 and R2 are given, we can say current through this is I1 and current through this will be same current. Let's say is flowing through both of them. Potential difference across these both we'll see. So what can we say? इसमें I1 ही लिख देते हैं. So E1 minus IR1 will be equal to E2 minus IR2. And this is what we will get. So इसका effective resistance कितना हो गया? I will be equal to, if you observe carefully, अरे यार, E1 minus E2 is equal to I into R1 minus R2. तो इसको इस साइड भेज दो, सिंपल. तो I into R1 R2 minus R1 is equal to E2 minus E1. तो I हो गया E2 minus E1 by R2 minus R1. तो इसको सब्स्टिट्यूट कर दो, तो इफेक्टिव EMF कितना हो जाएगा? E1 minus I into E2 minus E1 by R2 minus R1. तो इससे क्या आ गया? E1 minus into R1 हो गया ये. E2 R1 minus E1 R1 by R2 minus R1. तो इसको सिंप्लीफाई कर दो, ये कितना आ जाएगा? E1 R2 minus E1 R1, ये प्लस हो गया, माइनस E2 R1 प्लस E1 R1 R2 minus R1. तो इसका इफेक्टिव कितना हो गया? E1 R2 minus E2 R1, ये दोनों कैंसिल हो गए by R2 minus R1. This can also be simplified as E1 by R1 minus E2 by R2 by 1 by R2 R1 minus 1 by R2. तो इस टाइप का एक इक्वेशन भी बन जाएगा. दिस इज हाउ वी डिराइव इट गाइस. ऑलराइट, डिराइवेशन अगर ये सिमेट्रिक है तो इफेक्टिवली सिंपली हो जाएगा I will be equal to E by R plus R. ठीक है, R net will be R by M and the combination will be E. R net will be R by M. तो इससे हमें ये इक्वेशन आएगा. ऑलराइट गाइस, सो दैट्स ऑल. ठीक है, तो दैट्स ऑल फॉर टुडे. तो और प्रॉब्लम्स कल करेंगे. So adios amigos. So if you like this video, don't forget to like this video. Use the code NSS1 when you're taking the plus subscription. Subscribe to the channel which is IIT Let's Crack JEE in English. This is a channel exclusive for you guys who are having trouble in Hindi. उन लोगों के लिए इंग्लिश में मैं I am teaching you in English. So make this viral. Tell it to everyone, especially in South India, so that this will become a good channel. Definitely hit the like button, subscribe, hit the bell icon for notification for the next class. So next class will be at tomorrow at the same time. Okay, until next time, adios. See you guys.